You guys must be curious to unravel the mysteries left by Jayesh for me to open. Let's talk a bit about battery pack sizing. Sizing of the powertrain starts with the sizing of the motor. The motor is the one going to determine the performance of the powertrain. The general performance parameters as a part of powertrain sizing are stuff like 0 to 60 kmph time, 0 to 100 kmph time, quarter mile time. All of the above mentioned parameters in some or the other way relate to the acceleration of the vehicle. Then we can talk about the range of the vehicle, gradability, or the highest gradient the vehicle can attain or scale with a fully loaded condition. Passing requirement, the ability to accelerate when you have already attained some speed, generally observed for overtaking vehicles where you need short bursts of acceleration for overtaking that long, slow moving trailers. Then we have regeneration requirement. How much is the motor's ability to regen? How much of the kinetic energy can be converted back to electrical energy and maximum speed of the vehicle. This graph better explains and represents all the requirements and how they can be captured on our motor torque versus RPM chart. Now, of these parameters, almost all of them will determine the motor sizing, and some of them eventually go on to determine the battery as well. The inputs which the drivetrain team gives to the battery team are operating voltage of the system. This includes the operating voltage ranges and the upper and lower cutoff for the motor and below which the motor won't run. Determination of operating voltage depends primarily on how high powered your system is. You would opt for a higher voltage when you go for higher powers. You would rather have that power in form of voltage rather than in form of current. Another aspect is the type of motor you opt. Most of them indirectly represent one equality where the DC link voltage is directly related to the speed of the motor. Higher the voltage, higher the speed. Although this is a very crude way to put it. So how much is too much? Here our maximum speed requirements are useful. We cap the speed on the basis of top speed requirements. The discharge current, the continuous current required for driving in normal conditions. The peak discharge current. The peak discharge current is sucked up by the motor in instances of launch acceleration events, gradability while scaling peaks with your family in the Himalayas, and also while overtaking on highways. These are short bursts of quick acceleration. We identify our peak currents as well as how long it will last from these. Here we also have to look at the cool off period, the time we need to recover from these peaks to be ready for the next burst. And finally, the most important parameter which will determine kitna chalti hai, the energy to be stored by the battery pack. When we determine the target range, we can simulate instances of how much mechanical energy is being used for displacement of the vehicle for those many kilometers. Now, from the wheels to the battery, there are many instances of power losses. We take into consideration the transmission efficiency, the motor efficiency, the losses in the transmission lines, the losses in the motor control and contact resistances, and also any other thing I have missed. We divide the mechanical energy by all these efficiencies and get the energy required. This is the energy the battery pack is needed to be of to last the said distance. Some buffer is always added for all the instances of losses we neglected and might stack up. The regen current is associated with how much current the cells can sink. We determine how many peak current instances the motor might produce and for how long during decelerations. So these were all the parameters which are given to the battery where they do the further design. As already explained by Jayesh, we generally find ourselves shipping out the aforementioned parameters to the battery team. In case of a two-wheeler like a scooter, we find ourselves with motors of 2 to 10 kilowatt of power. Now for these kinds of motor, the voltage can be of any value. We can even have voltage of 400 volt, and when we divide the power by the voltage, we find the current and range, a current in the range from 5 to 25 amperes. While lower currents are always advantageous, but higher voltage also has its issues, which are related to the safety. Increased safety measures will make implementation of the system more costly. Thus, a good compromise without hampering the safety is generally found. And thus, most motors will find themselves with 48 volt systems. If you can recall our demonstration of optimum lap, we can also find out the mechanical energy required by the vehicle to cover a certain terrain. Generally, a drive cycle is used to determine the vehicle performance. The scooters presently in the market have battery packs with capacities ranging from 30 to 80 ampere hour, which give around 60 to 180 kilometers of range. Remember, the motors are agnostic to how this voltage and capacity of the battery is arrived at. Thus, it is at the discretion of the battery designer to determine the battery specification and especially the configuration for efficient packaging. The designer can choose the cell he wants, the chemistry he or she wants, the combination of series and parallel, as long as it meets the voltage, current, and capacity requirements.